Okay, welcome to the next video. Now what we're going to talk about is concept of pseudocode. Now pseudo, essentially that means that it's not really code. It's kind of code, but yeah, no, it's not functional programming code. And in the previous steps that we've gone through, we had the algorithm. That was, we compared it to a recipe. Text-based, something you can create in a Word document. In some instances, as I'd said, it could be mathematical formulas. And then the next step that we went through was the flowchart. Now that flowchart, that was to make sure that our logic of those step-by-step progressions in the algorithm was in fact valid and functional. Now that we know that the algorithm says what we want to do, it's functional, the next step is to create what's called pseudocode. Because if we are developing this solution, but let's say, for example, we are not the one that's actually going to code it, and we don't know what language it's going to be coded in, we would want to create what's called pseudocode. Now, here's some examples of pseudocode in code. X equals, that's an assignment, and we'll get some input from the user. We'd had an example of that in our algorithm and in the flowchart. X equals, convert X to Celsius, similar to something we've seen, and then output, also something we'd already seen. Now those things, they weren't necessarily worded that way in our algorithm because we didn't want to be that specific. They're very similar to what we created in our flowchart though, but they're also not quite programming code because they don't have the precise syntax that these blocks of code have. Specific formatting for a print statement, data type usage, invoking or calling an input function, assigning the result from that input function to a variable location, taking that variable, typecasting it to become, rather than a character or a string, whichever it may be, converting it into the data type of float, which is something we'll talk about in the next module further. I hinted on it a little bit in one of the previous lectures, but that's typecasting. So we converted what was in there so we could use it mathematically. We performed the calculation, and then we stored the result in F. Wow, F was a string. Now, what's in F is a float. Make note of that. That's something that we'll talk about later. Okay. That's specific programming code, which is different than what we saw up here at pseudocode. Pseudocode had pretty much the same step-by-step. It just wasn't the correct syntax for it to function as a program. Now, one of the things that I want you to get used to is this. You see the number sign or the pound symbol followed by some text. Precise temperature. That's a comment. And you see another comment down here below. You also remember I talked about keywords. There are some words that you cannot use in programming. I can't use print because there's already a function called print that when we use that name, it means something. Float is a class that exists in Python. We can't use that word. Input, we can't use. There's a function associated with that specific combination of characters. Now, keep in mind, programming is case sensitive. So those keywords, if I had a big P followed by a little r, little I, a little n, little t, that's different. So it's something you'll get familiar with over time by using it. All right. Now, there's two examples of programming code in Python. We could have done this same pseudocode and converted it into C++, C#, Java, JavaScript, and the syntax might look functionally similar, but not exactly. All right. These comments, I want you to put comments all over your code. There's white space in between these two blocks of code to break the logical grouping or structure up, kind of like two paragraphs on a sheet of paper. When you think about when you're writing an essay, you've got logical groupings of sentences. That's a paragraph. In programming, we have logical groupings of statements. So here's a comment statement, a statement that will be run by the application, by the compiler, another one that will be run by the compiler, and another one that will be run by it. So those things, they're logically working together. Now here's another logical group of code that will perform another task. Okay. Now, I talk about it a lot in the face-to-face classes, and I want to make sure that you understand it as well. It may sound like a joke or something that's funny. I'll commonly ask, what's the number one time at work and your employment status that you're most likely to lose your job? And a lot of people will come up with a variety of different jokes or whatnot. It's a serious question. What's the one thing that you can do at work that is normal, and people do it all the time, that could cost you your job? You're most vulnerable at that point in time. And that is go on vacation. Go away. Go do something. Spend time with your family. If you're not there at work, there is, in certain situations, nobody there to protect you, to defend you, to ensure that your job remains while you're away. Somebody's got to cover for you while you're gone. And if you're a programmer or a coder, that person may want your job. Oh, I can't believe how horrible this code is. It doesn't work, and there's all these problems. If there are comments in your code explaining what things are happening and why, that individual that came in that didn't even understand how it worked, that badmouthed you while you were away to supervisors or whoever it may be, they wouldn't have a leg to stand on when it came to badmouthing you or bashing you. You'd have something to fall back on. I don't know what that person was talking about. You can clearly see, here's what the logic was. Here's what I was doing step by step. Clear descriptions of what's happening in the code so that somebody else knows what's taking place. Now, it could be you're working on a team and others have to actually use and work with that code as well. They need to know what's going on in the code. We create things, and I'll commonly say, I'm a programmer, and just because I don't want to have to write code over and over again doesn't mean I'm lazy. It just means I'm efficient. If I have code that works, it's functional, I don't need to replace it. I just need to invoke it or call it, as I had mentioned before. So I may forget over time about how I did something in some code, but I want to use it again. I need the comments to remind me, well, what was I doing here in the code, or why did I do this? So those comments in white space, are very important. And you'll see it in the workbooks as I provide examples of what to do and have things for you to go play with along the way. Okay. Some more pseudocode, an assignment, got an input, the output statement that's associated with that input, step by step. And then we've got the actual code that's different. Now, we see here the term elif. That can be problematic. I'm not a fan of how this is written because elif does not exist in all programming languages, and it's a little too specific for me to be in pseudocode. They're almost implying that this is going to be a Python coding. Okay. So here's some code for how that would be written down with a loop. That's something we'll talk about later. But in a nutshell, the code associated in pseudocode is not actual programming code. It's the same logic as programming, but it just doesn't have the syntax. Okay. So I'll see you in the next module. Take time to review the workbook that I provided and get familiar with the ins and outs of Colab and Python code within Colab.